Unit 4, Access Control Part 2, Access Control Administration. We're going to talk about some centralized methods for administering access control. Radius and TACACS, traditionally used to authenticate remote users to central networks. And we're also going to talk about some general methods, the technical, administrative, and personnel-related methods for, and physical-related methods for controlling access. Centralized methods of remote access control include Radius, the remote authentication dial-in user service, originally developed by Livingston, a networking equipment manufacturer, very quickly became a standard adopted in the 1980s, 1990s. It was used for user authentication to internet service providers. Back in the days when folks dialed in to a local access number, you could be mobile, perhaps dial in from different numbers. The internet service provider would have to track you to make sure that you're being billed properly, because things were billed by the minute or by the hour at that point in time. It's also used for remote user access to corporate networks. For folks who are road warriors who may, in days past, use dial-in networks to get into networks remotely, Radius was the service used to authenticate folks and the gatekeeper that allowed them into the network. It's also more currently used for authenticated access to secured wireless network. The most recent protocol for wireless security, WPA, has one of the options being using Radius to perform authentication as opposed to using a pre-shared key. It uses UDP, user datagram protocol, so it basically communicates via packet sent back and forth between the client, the server, and the end user who's attempting to authenticate. It only encrypts the user password. Most of the traffic is unencrypted. This can be a problem at times, particularly if folks are doing traffic analysis. TACACS, on the other hand, was developed by Cisco and is largely used in Cisco-centric environments. It uses the session-oriented TCP protocol, and it encrypts all user authentication traffic. Sounds like a good deal. The current version is TACACS Plus. The difference being where Radius is the underlying foundation of many remote access protocols that are vendor independent, TACACS has unfortunately been very much married to Cisco, and where you typically see TACACS in an enterprise environment is the authentication of privileged access to Cisco devices. Administrators will use passwords that are administered by TACACS rather than configured on each individual router and switch in the enterprise, so as to provide a central point of administration for that privileged access. Now, the way Radius works is the user contacts the Radius client. The Radius client in this case looks like it's a wireless device and requests authentication to the network. The Radius client then goes to the Radius server and says, here are the user's credentials. What do you think? Is this somebody I should allow in or not? The Radius server then replies to the client affirmatively or not, and if it replies affirmatively, the client is then allowed access to the network. So in this case, the user is not the client. The client is actually the router or wireless router that accepts the request from the user and determines whether the user is allowed in. Access control methods. We have administrative methods involving policies and procedures and administrative processes. We have physical access control methods, which involve access to physical resources, facilities, as well as things like network cabling and so forth. And we have technical access control measures. When we're talking about access control in the big picture as opposed to access control lists within a system, operating system, we need to consider all three of these. You have administrative mechanisms for controlling who has access to what devices and what resources. You have physical access control methods, and you have technical methods. The administrative methods involve personnel controls, which is the security expectations involved in a hiring, termination, transfer, or promotion process. The supervisory structure, which is how you delegate authority to supervisors and other managers for employees' security actions, ensuring that employees are properly managed and that their management is held accountable for following the proper procedures. You have security awareness training, which should be held across the organization and should be held frequently in order to ensure that folks understand their responsibilities for security and understand why the policies exist and why they need to follow them. And then you have testing of security procedures. This can involve things like simulated incidents. One very common thing folks sometimes do for security awareness is performing a phishing test where they contract with an outside service to send bogus-looking email to internal employees under tightly controlled, contracted for conditions, and then measure who actually opens the email, who clicks on the link, and who enters their user ID and password, and use that as a test to determine how many folks would actually open a bogus email and where we need to apply more training and more enforcement of policies and procedures. So this is the administrative side of things. It involves dealing with the human element, dealing with the policies and procedures and supervisory structures that control the human element in terms of ensuring that folks follow access control practices and policies. Physical security can involve a physical separation of networks. You can logically separate networks through firewalls or router access lists, or you can also physically separate them by hosting all the devices associated with a particular type of sensitive or security sensitive network in a specific physical location and restrict access to devices that way. So physical separation is something that's feasible in this age of virtualization and cloud-based services. It seems rather quaint, but there are many cases where actually physically separating out servers and end-user workstation and networking equipment into a restricted area is the best way to do things. Perimeter security is control over who is allowed to enter or leave an area on the outside. It's the security guard at the front gate, it's the alarm systems, it's the locks that secure the perimeter of a facility containing sensitive information and sensitive systems. Controls over individual computing devices. Individual computers, desktops, and laptops can actually be physically secured. They can be locked to the desk. USB ports can be sealed off. Other sorts of ports can be sealed off to prevent use of unauthorized devices. Even laptops, despite being mobile, can be physically secured in a sense, through cable locks and other devices that somewhat deter folks who are attempting to steal these devices, or at least opportunistic thieves who aren't particularly interested in investing in bolt cutters and sneaking them into a crowded area. Separation of work areas, that's similar to physical separation of networks, except you're separating the people instead of just the computers themselves. The notion here is, well, somebody can get through the perimeter, they can get in the front door, but what areas inside the perimeter are they allowed to? Do you separate out who is allowed in what area? Restrict via, say, a card key type badge or some other mechanism to prevent people from getting into work areas they're not supposed to. Cabling physical security is a protection of the network cable physically. The protection of the cable runs itself using, physical protection measures, maybe some sort of alarm, so if somebody cuts into, splices, or removes a cable, that an alarm goes off somewhere, ensuring that the cable itself is in conduit that protects it from unauthorized access and so forth. And then the last thing the textbook gets into is dividing the facility into control zones. This is a superset of the physical separation of networks and work areas, where you're actually formally assigning physical control to specific areas within a particular facility. Now the technical controls. System access. Which servers and services are allowed for access? Dealing specifically at the system level, who is allowed to access what devices or to access services that are running on specific devices. The network architecture involves the planning of logical network controls to enforce access policies. Things like firewalls, routers, proxies, even locking down switch ports to segment networks by access requirements. Traditionally this is firewalls. This is router access lists that can prevent certain traffic from going from one subnet to another. Proxies that sit between one particular area and another to sanitize traffic going between those areas. And it can also involve something called network access control, which is controlling what devices are actually allowed to plug into which switch ports or access which wireless access points. Network access control is a very important part of contemporary network security. Among other things, if you find a rogue device or a device that's been compromised in your network, it easily and quickly allows you to cut that device off from the rest of the network by remotely disabling its particular associated switch port or wireless access point. Implementing encryption to control access can be used to control who has and does not have access to networks through the management of various encryption keys. This is sort of a logical, technical access control mechanism as opposed to a physical access control mechanism. And then lastly, auditing in the sense of event logs, tracking who has performed what actions on systems and network as a way to ensure accountability and to, ensure that if there is unauthorized access, that its source can be tracked down and that source can be dealt with promptly. And that's it for network access control.